go again, ninjas. Another 8 Caillou challenge called Filter Out the Geese. Write a function that takes a list of strings as an argument, called birds here, and returns a filtered list containing the same elements but with the, quote, geese removed. The geese are any strings in the following array which is pre-populated in your solution. You can see they wrote out the array entries here, and if you go over to the coding section, they go to the trouble of making that array and populating it for you. So I'm not a geese expert, but I assume these are all geese. For example, if this array were passed as an argument, mallard, hookbill, African crested, pilgrim, Toulouse, blue Swedish, your function would return the following array, which is just like the one I read off with some entries removed, and those that are removed are located in the geese array, meaning they are geese, so they got filtered out. Go ahead and convince yourself of that if you'd like. The elements in the returned array should be in the same order as in the initial array passed to your function, albeit with the geese removed. Note that all of the strings will be in the same case as those provided, and some elements may be repeated. So that's clear. We'll move on to solving the problem. Please pause the video now and try this on your own first. That's the best for your learning. And come on back when you're ready. For these 8 Caillou problems, I like to do a lot of hand holding. So we're going to go through a solution that I call the naive solution, where you're just using the most basic building blocks, and then we'll gradually work up to leveraging those existing libraries so we can solve this problem very quickly in a very short amount of code, one-liner. So to that end, let's start simple with just the basics, because if you're new, you don't know all these libraries, right? So you may have come up with something like the following. So we know we got passed in a list of birds, and we're going to have to sort of step through that and check that if each entry is a goose or not. If it is, filter it out. So I'm going to make a list of string as sort of our result. Remember, we have to pass part of our contract. We have to return an IEnumerable. And spoiler alert, this list collection type implements the IEnumerable interface. And you can look that up in the docs. You don't have to believe me on that. But you can think of that IEnumerable interface as sort of a really overly generalized collection, that a lot of these other more concrete types can sort of override and implement in their own specific ways. And the benefit of doing that is that if all these collections follow the same structure, then you can call the same methods on different kinds of collections. And that's pretty powerful. So anyways, let me show you. Here you go. It implements IEnumerable. So a list is an IEnumerable, or it implements that, I should say. So new list of string. Going to initialize that to just an empty list to start. Now let's go over our collection of birds for each string bird in birds, right? That's the for each loop. It'll iterate over the collection and give us one at a time. So for each one of these birds, though, we have to check if it's in that geese list, right? So again, this is the naive way. We're gonna also loop through each of the geese for each goose and geese. And we can check if bird is in that collection or not, right? So if goose is equal to bird, that means the bird matches with an entry in the geese collection and we don't want to use it. So here, let's make a little flag for us to start. Bool include bird, and we'll just, by default, we'll say, we'll decide to assume that something is not a goose to start. And then as we compare it against all the geese in the collection, we can update that if appropriate. So in this case, it means, yeah, that bird unfortunately is a goose and it can't be included. We're going to say include bird now is equal to false, right? And I'm going to go ahead and break out, because imagine if we matched early in the array, say with Roman tufted, we already know we're not going to include our bird in our return list. So does it really make sense to check if it matches these other different names? Of course not. It's just extra cycles that we really don't need to do. Not a big optimization, but it's something. So at that point, we can simply check if include bird, right? Then we'll take our list, which was result, and add the bird to it. And then note that in this inner loop, or I'm sorry, in the outer loop, each time we'll process a bird, then we'll come back to the next bird in the collection. So over here they had mallard. So on round 2, we're going to come to hookbill, and then this include bird is going to be set to true again. In case it did get turned false, this is going to sort of, because I declared this variable inside the loop there, each time through, it's like it's a brand new variable. So that's how that works. And anyway, at the end, I think we can simply return our results list. And I think that will cover us. You know, not the most efficient thing, but we're using the basic building blocks here. So let me try it, make sure I didn't do anything bad. Okay, good. So yeah, that's one way to do it. Now, if you wanted to get a little bit fancier, we have some shorthand we can use. So instead of kind of having this flag right in this inner loop, we could do something like if geese contains bird. Do you remember this contains method? This is part of enumerable collections, and arrays implement that interface, so I can use contains. Go ahead and head over to the docs if you want to see this. We'll go to enumerables methods, and this is all, you know, this is part of LINQ, so we're going to have to bring in system LINQ, and you'll notice it has a contains method. And you know, as you're going through here, scroll through the methods, you know, take a look, just so each time you remember some of this and you get an idea in your head of what's available for you. Maybe it's not, these aren't relevant on the current problem, but we'll hit a problem later and you'll go, hey, wait, I remember there was this reverse thing. I wonder if that just reverses the order of elements for me, and I don't have to write some custom code for that. So yeah, it's a good habit. Just kind of take a quick skim. There's not too many of them, and they're powerful and widely applicable. But anyway, we have contains here. So it just simply tells you whether a sequence contains a specified element or not. That's exactly what we want. And so you can read more about the method if you like, but it returns a simple Boolean, right? So we'll head back. And of course, we want it to not contain, we want the bird to not be a goose, right? And so we use that exclamation mark as sort of a negation. I think this is very readable now, but I know it's kind of weird when you're new. It's like not geese contains. That's not how we speak English, but if you can kind of get over the ordering of things, you can think of it like the geese collection does not contain this bird, you know, and you just get used to it after a while. The ordering's a little weird, but not so bad. very understandable soon enough. And then we can say it's safe to add the bird if it's not part of that goose collection, right? But remember, we saw that it was part of that system LINQ namespace. You're going to get an error if you don't include that. So let's add that and test it. Just a little change, but it got rid of that little Boolean flag we had. I think it's very expressive and readable. I like this better, shorter. So good. That's another way. And now we're going to sort of expand on that to even fully leverage LINQ to sort of get away with it one line, or at least one line of our own code. I'm not counting the code that they wrote for us here with this geese array. So let's try that. Let's go back to this enumerable, and there's a method in this collection that we're going to use. If you want to pause and look for it and see how you might go about doing that, go ahead. Otherwise, I'll get on with it. We're going to go down to where. This is a really good one. So I like to think of where like a filter, just like it says here. Filters a sequence of values based on a predicate. And you can imagine that. And I've mentioned this in some of my other videos, which you may not have seen, but a predicate is just a fancy word for a function that returns true or false. So we're going to provide that function, and that function is going to say whether something's a goose or not. And then this where method will sort of do all the lifting for us to remove elements that aren't that don't apply, that we don't want. So you feel free to scroll down, read more about where if you'd like. I always like looking at the examples that they provide, and we're going to talk about this too. This is shorthand. It's called a lambda function for passing a function. So we don't have to do all the work of writing out another full function in our class, right? If we just have this sort of one-off throwaway function that we need just for in the one place, the C# language provides this nice mechanism for doing it in a very concise way. And I know it looks intimidating at first, but there's really not much going on there. So let's try this with our birds. We can then use where. You could say return. We're going to want to do, we're going to return the birds where, right? Because we're taking the collection we want to filter, and then the where method is what invokes that sort of filter. And then the only thing left to do, right, is to make up that function that says which elements you want to keep and which ones you want to discard for your filter. So the shorthand, I'll go back and show you with that. With this, the first part, the part to the left of the arrow, just think of this like listing is where you list your function's parameters. And then you got the arrow, which sort of denotes, hey, everything after the arrow is my function body. So you could write out a full function if you wanted to, you know what I mean? Like private bool filter geese, and then you'd say string bird, right? And then you could put your logic in here. But again, when you write code all the time, you don't necessarily want to write a bunch of these methods out, and then other people look at your code and, what are these extra methods for? They look more important than maybe they really are. And they just, they accumulate and they add clutter where maybe you don't need it. This is just kind of a one-time thing. Now, if it were a method that you used in a lot of places, yeah, by all means, break it out into its own method. You don't have to keep copying the same lambda expression all over the place. But for this example, it's just sort of a one-time thing. So I want to name my parameter bird, but this is custom. You know, you can't use keywords, obviously. I can't name my parameter return. That would be terribly confusing because we know return means something else. So I'm going to call mine bird, right? And I just have the single parameter. In this case, you can think of that like, I guess I see this more in C++, but the idea of a unary predicate or a binary predicate where the unary one has a single parameter, and that's all we need here, right? Birds is a collection of birds, and we're just looking at one element at a time. So I got my parameter. I'm calling it bird. So now I use the arrow to denote that I'm going into the function body. And so I can access this parameter name in my function body. That's what we do, right? Just like they passed us a parameter named birds, and I need that. I reference that in my function body here to get my work done. Same thing inside the parentheses here. So we would want, just like we did when we upgraded our naive version, right? Not geese contains bird, right? Or as we say in English, geese does not contain bird. And yeah, so it will go through and make sure bird's not in there. If bird is in there, then it's going to fail this filter and the new collection. Remember, where's going to return a new collection? We still have where up over here. Let's see. Where's the return type? So yeah, it's going to give us that I enumerable of whatever generic type we're working with. We're working with string, so it's returning that collection, and that's perfect, right? Because that's what our contract says. We have to return that. So yeah, it's an I enumerable of string with geese filtered out. I'll go ahead and run this. Green, my favorite color on here. And then let's just run the whole thing. Make sure it's still okay. All right, now we can declare victory. So yeah, there's a nice one-liner, if you'll let me get away with calling it that, since this was sort of along for the ride. You know what to do. Go ahead and submit, gain those honor points, and then go through, look at other people's solutions, see what you can take from it. Even if it's not the best solution here, it could be a little tool that would be better in another scenario. So, well, that's nice. Look at that, birds except geese. So I like that better than, a lot better than what I did. That's really nice, right? That just reads, you don't even have to know anything about coding, and that just looks nice. I forgot about that. So birds except geese, yeah, that's winning. Most people did it that way. Here was more like what I did, sort of. But yeah, see, that's the utility of looking through these. Look through all the ones you like, and then otherwise hit me up with those questions, concerns. Otherwise, I'll see you in the next one. Thank you.